Hello, everyone.
My name is Jesus Palomer, and I will continue speaking on the methods of analysis of changes in the coast from of coastlines extracted from satellite images. In this second video, we will mainly talk about the method of change analysis from the approach of spatio-temporal models. First of all, we must remember that transect models are suitable when we have a moderate number of coastlines. On the other hand, the results when applying this method are quite dependent on orientation and number of transects, which can cause loss of intermediate details. When the number of coastlines begins to be high, the most appropriate method is the one based on the spatio-temporal model. This method is suitable for coastlines in point vector format and offers a global analysis showing impacts, trends, and evolutions in a quick and visual way. The method is based on the creation of a Hofmahler-style diagram where the spatio-temporal distribution of a variable is shown. In this way, one of the axes contains the dates on which one data has been taken, while the other axis contains the places, latitude, longitude, or distance, in which this data has been taken. The creation of the spatio-temporal model requires two elements: a series of coastlines in point, and a baseline parallel to the coastline and usually located inland. Regarding the baseline, if it coincides with the inner limit of the beach, see promenades, we will be able to measure widths of real beaches. This information is important from the point of view of recreational use of the beach and of its socioeconomic implications. From the spatio-temporal model, we can see the evolution of two parameters, the average width of the beach and the average change in beach width. This last parameter can be obtained by subtracting the value of the width of the beach on each date from the value of the beach width of the initial date of the analysis. Now let's see how to organize the information to build the spatio-temporal model. As for the baseline, if we want to obtain distances that represent real widths, we need to draw this line on the inner boundary of the beach either to the construction elements, see promenades, building facades, or to natural limits, for example foot of dune. Try drawing the line as a single entity and using smooth strokes, avoiding big changes of direction. Once we have the baseline ready, we will divide it into sectors of arbitrary length according to the detail we need. A commonly used distance is 50 or 100 meters. We will associate a distance to each of these segments. This distance will be the length between the center of the sector and the first point of the baseline, always following the direction along this baseline. The next step will be to perform a proximity analysis, which consists of calculating for each point on the coastline the distance to the nearest baseline sector. This way, each point will be associated with a sector. The last step will be to calculate the average distances. In this way, for each sector, we will have the average distances associated for all points for each date. Finally, we will organize the information in a grid point in the following way. On the x-axis we will arrange the dates. On the axis y the distance of each sector from the origin point of the baseline, and in each cell, that is, at the intersection between sector and date, we will have the value of the average distance. This grid points matrix represents discrete information of the average beach width phenomenon. The existence of periods of time in which the analysis area is covered by clouds causes a lack of data, and therefore the existence of gaps in this data matrix. To minimize these problems, it is necessary to convert discrete information into continuous information applying some interpolation method. An accepted method is to create a tin model from the grid point matrix and subsequently the conversion from the tin model to a raster layer. As mentioned above, this is the spatio-temporal model of medium widths. In the case we want to obtain the model of changes of average width, we will only have to subtract the average width of each date from the average width of the starting date of the analysis. Sometimes, to avoid biases, We can take the initial average width as the average of the average widths of the first n dates. For example, the dates of the first year. The average width change model is very interesting from the point of view of the detection of erosion and accretion events, and it is the one that we will use in the following example of use of this methodology. To illustrate a case of use of the spatio-temporal model, let's see a clear example of how the construction of a jetty affected the evolution of a sector of the Valencian coast. We must take into account that Spain is a country with thousands of kilometers of coastline, and is also one of the countries where more actions have been carried out to mitigate the effects of coastal erosion. Among the most used solutions, we can mention the sand nourishment and the construction of barriers such as jetties. These barriers interrupt the natural transport of sediments, promoting the accumulation of sand in some places, but favoring the erosion of sediments in others, which only leads us to transfer the problem to other areas. In the case we are illustrating, we present these beaches in the town of Cullera, on the Valencian coast. In these aerial photographs from 1956 until 2022, we can see the evolution of these beaches. We can see how this area was affected by the construction of a jetty from 1976 until 1994. Visually, we can see an accumulation of sand or accretion to the north of the jetty and a loss or erosion to the south of the jetty. After the removal of the jetty, little by little the beaches return to a situation of balance. In this case, we only have 8 images, but how can we analyze the evolution of this sector in much more detail? With this objective, all the coastlines were extracted from all the available satellite images of the Landsat sensors 5, 7 and 8 and Sentinel-2, covering a period from 1984 to 2023. 1,049 coastlines were obtained using ShoreX software, and the spatio-temporal model was calculated. 3 derived effects can be clearly seen in the model due to the removal of the jetty in 1994. A clear erosion of the first sector of the beach that has never been recovered. A clear accumulation in the second sector of the beach, which demonstrates an evolution towards a balanced situation. Finally, a slow but continuous transport of sediments can be observed from north to south, demonstrating that the sediments lost in the first sector of this beach have been feeding the beaches further south. We end this video here. Many thank you for your time.